Hi everyone, good afternoon. So I think we can go for the next section. So for that I would like to introduce you Cyril Morel from Rakuten Aquafadas. So Cyril is a technical developer and technical leader inside the front-end team from Rakuten Aquafadas. And he's gonna present us today a new project he was working on how to extend from web application to desktop application. So Cyril, want to join me?
Hi everybody. Okay, that's good. Hi. So I'm working at Rakuten Aquafadas, and at Rakuten Aquafadas we are making tools that allow you to create rich, interactive documents and display them on any device or platform. Until today, our technology gave you the possibility to build and customize web apps and mobile apps for iOS and Android. We call these apps Next-Gen apps. On the left here, you can see our CMS that we called Cloud Connect, where you can customize in real time the content of your app. You can say here where you how you want to showcase your documents. On the right, you'll see the result in the Next-Gen app for Android. It will run exactly the same in iOS and the web. So today I will talk specifically about our web technology and how we did to reuse it in order to expand our offer to the desktop. So let's start with the Next-Gen web. So the Next-Gen web is a web app. It's basically a library where you can browse, search, read, even buy rich interactive documents like magazines, newspaper, books, or even just simple PDFs. These documents are made available by publishers via our homemade CMS that we've seen earlier, that we called Cloud Connect. The app is responsive and entirely customizable. Under the hood, the Next-Gen web is using the latest tech. So we use NodeJS and Gulp for our build phase. We use NPM and Bower to run their dependencies. The front-end part is made with Angular. We use the full power of Angular and its modularity. That means we create really a lot of components that we use all across our Angular apps. For example, we use the same components in Cloud Connect and our Next-Gen web. The Next-Gen web is communicating with Cloud Connect, our CMS, via an API. For security matter, there is also a PHP engine which will intercept and encrypt every request that we made to the CMS. We can customize everything via a JSON file, so we can customize the menus, the colors, the logo, the features, etc., etc. So now let's talk about our Next-Gen desktop. So first, why would we want to make an app for desktop? It's simple. We wanted to offer an offline solution for our clients. So that way they could download the documents and access them everywhere at any time. Also, we wanted something really cross-platform, iOS, Android, web, Windows, macOS, and why not Linux. So that way the user could really choose the platform of his choice. What were the requirements for the desktop app? So first, we didn't want to develop again the features and the UI that we already did for another platform. So we wanted to find a tech that will be that will let us reuse our web code base. We wanted to use a technology that we already knew and we are good at. So for all of this, the web technologies were a good candidate. We did a lot of search and finally we found a good solution. We found Electron. Electron creates a native shell for our app and allows us to communicate natively with the OS. Electron is cross-platform, That means with the same code, we can build apps for Windows, macOS, and Linux. It's a mature and stable solution. It's already used by big names. For example, GitHub editor, Atom, is made with Electron, or even Microsoft Visual Studio Code, or Slack. Or there is a lot of examples like this. So here is the base of our app. It's Node.js, Chromium, and the Electron framework. Electron is written in Node.js, and we'll use Chromium and its V8 engine to render the views. At this level, we are creating the shell. That means the window, we can customize it, we can change the style, we can add menus, etc., etc. And for the views, this is where the magic happens. Electron will allow us to load an index HTML with JS and all. So that's where we embed our next-gen web. It uses, inside the next-gen desktop, we use exactly the same app that in our next-gen web. It's exactly the same code, we just copy it from one to another. At this stage, we can execute the desktop app. It will render, but as we've seen earlier, the next-gen web encrypts every request that we made to the CMS. So for our app to work properly, we had to add HTTP server to copy that feature. So that's why we added HTTP server written in Node.js. Electron and Node.js allows us to use native libraries. So again, we didn't want to rewrite everything, so we use the exact same homemade C library that we use in our Android and iOS app for encryption. And finally, to add some interactivity between the Angular app and the native shell, we added a WebSocket server. It's written using Socket.io, it's in Node.js. So we can add some nice feature, like we can notify the user when a download is starting or ending. So now our app is ready to go. Just by executing this simple command, we can execute the app and we can launch it and test it. And if we want to distribute our app more easily, we can create an executable by executing this command. So it's npm run this dash the architecture we want to build our app for. So here it's x64 for Windows 64 bits or OS X for OS X. We can also build for Windows 32 bits. It will be AI32 or something like that. There is a thing with this command, because during this step, Electron is compiling the native libraries, so we need to be directly on the platform to execute this, to avoid some issues with the compiling. Other than that, Electron is really great. It offers a lot of nice options, and just by tweaking like a simple JSON file, we could say Electron to build an installer for Windows or for macOS or Linux. We can customize the installer also. It also offers the possibility to sign our apps, and we can, at the end, we can submit our package app to the app stores, so the Mac app stores or the Windows store. So now our app is ready to be distributed, but the process of redaction is quite, is not really good. I mean, a developer needs to, if we want to customize our next-gen web, you have to modify a JSON file, and then you have to package the next-gen web, and then embed it in the next-gen desktop, and then customize the next-gen desktop, go on the platform of his choice, execute the command, etc., etc. It's really not easy, and it's not really not user-friendly. So that's why we created a new app, a new tool that we call NextGen Factory. So that way, with this tool, a non-tech person can create any app he wants. We can create multiple next-gens for multiple clients. We store the apps directly on the app, so we can find them later, and we can customize them, we can edit them. And with using this interface, we can customize our app really easily. So we don't have to modify the JSON file by hand anymore. So we can customize the logo, the colors, everything. Under the hood, this app is using Angular app for the front-end part and NodeJS for the back-end part. So we don't like to reinvent the wheel. So here again, we use the exact same components that we use, the Angular components that we use in our next-gen web and even in our CMS. So it's all the same module that we are reusing again and again. Here again, we used a WebSocket server, so to add some interactivity with our user. So, for example, when a build is finished, we can notify the user, and when there is an error or the server is down or something like that. At first, the NextGen Factory was designed only for NextGen Web, but with the arrival of the NextGen Desktop, we had to modify it a bit. So, as you can see, it's a bit more complicated now, mainly because of the fact that we have to execute the command to build the app directly on the machine. That means since we wanted to build apps for Windows 32 bits, Windows 64 bits, and OS X, we needed to have at least 3 machines or virtual machines. Here in the example, we have our Windows platforms on a virtual machine, and the OS X is like a Mac Mini or something like that. Since we have new machines, we needed to find a way to communicate with them. So at first, we decided to go with SSH, but the command line can be very different between platforms. So we got big headaches trying to execute the same command on every platform. So we decided to go with HTTP. So it was like way more simpler, and we just had to install a web server on the machine. We call like the small server, the HTTP server. It's the green square here. We called it the builder. So basically, on every machine we have the builder and the desktop app. It's represented by the red square on the graphic. So the NextGen Factory backend is communicating via HTTP to the builder, and the builder is communicating with the desktop app. So to summarize here a small diagram. So let's say a user wants to build a desktop app. You just have to press like a big button, and a request will be made to the backend of the NextGen Factory that will send an HTTP request to the builder. The builder will then execute a series of commands to customize the app, to copy the assets, create the installer, store the installer, etc., etc. At the end of these commands, the HTTP request will be answer back to the backends with some info, like the installer name, the installer size, or the installer path where it's stored, etc., etc. And at the very end, the user will be notified via the WebSocket server. So now he can download it directly on the NextGen Factory, and he can even install it on his machine. It will be like this, like another OS X app. and you could now enjoy it. So that's it for me. Thank you.
Thank you, Cyril. So if you have any question, please feel free to ask Cyril. Okay, so I think it was pretty clear, so that's very nice. Thank you.
Thank you.